Hello, I am Dr. Uksun Kim. In this video, we will be discussing the moment of inertia and radius of gyration. This slide shows the overview of my lecture. In the beginning, I will talk about the definition of moment of inertia. Then I will solve an example problem with detailed explanation. I will also talk about the definition of radius of gyration. After these slides, I will show the applications of moment of inertia and radius of gyration in the area of structural analysis and design. Finally, I will provide a practice problem to check the level of your understanding related to this topic. This slide provides the definition of moment of inertia. So a beam's resistance to bending and ability to support loads depends on property of its cross-section called the moment of inertia. So moment of inertia, the main physical meaning is that a beam's resistance to bending. So this is very important for the beam design. And then using the I, okay? So for the differential areas dA, so this is the dA, and then you want to find the moment of inertia of the differential area dIx. Then about the x-axis moment of inertia, y squared dA. And then diy about the y-axis, there's a x squared dA. So the moment of inertia for the entire area, not the differential area, entire area that use the area integration. So there's a area integration for the Ix, but be careful using the y square. Okay, so that is the equation to find the moment of inertia. This slide shows an example problem. So let's try to formulate and find moment of inertia I with respect to the centroidal x prime axis. So moment of inertia about this axis, x prime. And then previous slide, I talked about that this is the equations to find the Ix. So now we need to find this one. Actually, there's find the Ix and prime, because that one is the letter Ix prime, centroidal axis. This slide shows the solution of example problem. So we need to find the y prime. So there's and then dA based on the moment of inertia integration. So to find the moment of inertia for the rectangular area like this, differential element shown in figure is chosen for integration because its location and orientation. The entire element is at a distance y prime from the x prime axis. So that means that this gray area, okay, that is the differential area, that is the distance is the y prime. Integration from y prime, this is related to the x prime, so there's a negative area, this is a positive area. So the range is at the minus h/2 to h/2. And then dA for this gray area, that one is the b times, and then dy prime. So we use this one formula, Ix prime equals integration y prime square equals like this, h/2 minus h/2 and h/2, there's a range, and then y prime square, and then instead of dA, put the b dy prime. And then this one is that the b is the constant, so it can come out from the integration. So integration, same thing, this one, and then y prime square, and then dy prime. And then this is a polynomial integration. So y prime square, there's easily the 1/3 y prime cube, and then b is a constant. The range is at the minus h/2 to h/2. And then you plug in this one, and then 1/3 h/2 cube, and then minus, and then also minus h/2 cube, right? And then this is the answer. So final answer is that the bh cube divided by 12. This is very important. So you know that the moment of inertia for the rectangle area, like width is a b and the height is at the h to the centroidal axis, that is the answer is the bh cube divided by 12. That equation is worth to memorize. This slide provides the definition of radius gyration. So although the radius of gyration of an area does not have an obvious physical meaning, we may consider it to be the distance from the reference axis at which the entire area could be concentrated and still be the same moment of inertia as the original area. So that one is the entire could be concentrated. Here is the equation for finding a radius gyration. So this is the equation for the radius gyration. And then if you can find the moment of inertia, you can find it easily because this is the equation. There's a square root ix. There's a moment of inertia divided by area. So you can find the moment of inertia, and then it's not difficult to work. And then the radius of gyration, some textbook use a k, or some text use the r. Okay. This slide shows the application of moment of inertia and radius of gyration in the area of structural analysis and design. Moment of inertia, as I mentioned, they're using the I, is important for a beam's resistance to bending. So this is a very important property for beam design. Unit for the moment of inertia is the inch to the force power, and then millimeter to the force power. Radius of gyration, some book use R, some other book use a K, is important for column design, especially for calculation for the slenderness ratio. You will learn about this in the later, but this is a key value. And then unit for the radius of gyration is inch or millimeter. This slide shows a sample table for dimension and properties of wide flange shapes. The wide flange shape is popular for the beam and column members. And then the cross-sectional shape looks like this one. And then I also put the picture actually using for the beam member for the wide flange shape. You can find this kind of tables in the design manual. And then moment of inertia value I, and then radius of gyration value R, given for this for the design purpose in this table. So you can find it, I and then R value from the design table. This slide shows the practice problem. This problem is asked to determine the moment of inertia for the rectangular area with respect to the axis XB that is passing through the base of rectangle. So not from the centroidal axis. So that one is a change from the example problem. So you need to formulate and find a moment of inertia I with respect to the axis XB. And then in this part of that, this is XB. So this is a positive area. So your integration, okay, that is the I x b equals integration, and then data from the 0 to h. Okay, that is the range is 0 to h, and then y square dA. So that is the equation you need to use that. Okay, so I hope this video is helpful for you.